Our universe is a wondrous expanse filled with celestial objects of incredible diversity. Among these, stars, planets, and brown dwarfs stand out, each with unique characteristics that set them apart. Stars, the cosmic furnaces, are gigantic balls of plasma, primarily hydrogen and helium, undergoing nuclear fusion in their cores. This fusion process releases enormous energy, making stars shine brightly across vast distances. Planets, on the other hand, are celestial bodies that orbit stars. They are much smaller than stars and lack the internal pressure and temperature required for nuclear fusion. Brown dwarfs occupy a fascinating middle ground between stars and planets. They are larger than planets but smaller than stars, existing in a sort of cosmic limbo. While brown dwarfs do form from collapsing gas clouds like stars, they don't possess enough mass to ignite the full-blown nuclear fusion that powers stars. However, they can fuse deuterium, a heavier isotope of hydrogen, for a short period, making them slightly warmer than typical planets. The distinction between these celestial objects lies primarily in their mass and their ability to sustain nuclear fusion. Stars are the heavyweights, capable of fusing hydrogen into helium and beyond. Brown dwarfs are the middle children, massive enough to initiate limited fusion, but not enough to become true stars. Planets, the smallest siblings, lack the mass to ignite any form of fusion and instead reflect the light of their host stars. Jupiter, the largest planet in our solar system, has a captivating origin story, a tale woven into the very fabric of our solar system's birth. It all began approximately 4.6 billion years ago, amidst a swirling cloud of gas and dust known as the solar nebula. As this nebula collapsed under its own gravity, it began to spin faster and faster, flattening into a rotating disk. At the center of this maelstrom, our sun was born, igniting into a fiery inferno. In the outer regions of this protoplanetary disk, far from the sun's intense heat, tiny dust grains, remnants of long-dead stars, began to clump together. This process, called accretion, marked the first step in Jupiter's formation. Over time, these dust bunnies grew larger, their gravitational pull attracting more and more material. As the clump grew, its gravitational pull increased, drawing in more gas and dust and accelerating its growth. This runaway growth led to the formation of a planetary core, a dense ball of rock and ice at the heart of what would become Jupiter. This core acted like a gravitational vacuum cleaner, pulling in vast amounts of hydrogen and helium gas from the surrounding nebula. The accumulating gas formed a thick, swirling atmosphere around the young Jupiter, eventually growing so large that it dwarfed all the other planets in the solar system. Jupiter's formation, a testament to the power of gravity and accretion, resulted in a gas giant, a planet composed primarily of hydrogen and helium, much like the Sun. However, despite its size and composition, Jupiter's journey to planethood took a different path than its stellar sibling. The idea of Jupiter as a failed star has tantalized astronomers and the public alike. After all, it's the largest planet in our solar system, composed primarily of hydrogen and helium, the same ingredients as our Sun. It even emits more heat than it receives from the Sun. However, despite these intriguing characteristics, Jupiter falls short of the stellar mark. The key difference lies in mass. Stars are much more massive than planets. Our Sun, for example, contains roughly 99.86% of the total mass of our solar system. Jupiter, while massive compared to other planets, is a featherweight in comparison, containing less than 0.1% of the solar system's mass. This difference in mass is crucial because it determines the core pressure and temperature of a celestial object. Stars, with their enormous mass, exert immense gravitational pressure on their cores. This pressure, combined with the high temperatures, creates the perfect environment for nuclear fusion, the process that powers stars. Jupiter, while massive for a planet, simply doesn't have enough mass to generate the core pressure and temperature required to ignite nuclear fusion. Its core, while hot, is not nearly hot or dense enough to fuse hydrogen into helium. The heat Jupiter emits, while significant, is a result of gravitational contraction, not nuclear fusion. As the planet slowly cools and contracts, its gravitational potential energy is converted into heat. This internal heat source explains Jupiter's surprisingly high temperature, but doesn't make it a star. Section 4. Jupiter's reign, the king of planets. While Jupiter may not be a star, it is undoubtedly the king of planets in our solar system. Its sheer size and gravitational influence have shaped the solar system's architecture, influencing the orbits of other planets and protecting the inner solar system from cosmic debris. Jupiter's reign is one of majesty and power, a testament to its planetary prowess. With a mass over 300 times that of Earth, Jupiter's gravitational pull is immense. It acts like a cosmic shepherd, its gravity herding asteroids and comets, preventing many from venturing into the inner solar system, where they could potentially collide with Earth or other planets. This gravitational influence extends to its moons, a system of over 80 known satellites that orbit the gas giant like a miniature solar system. Jupiter's atmosphere is another striking feature, a turbulent tapestry of swirling clouds and powerful storms. The Great Red Spot, a giant storm larger than Earth, has been raging for centuries, a testament to the planet's dynamic and chaotic atmosphere. This atmosphere also hosts powerful magnetic fields, the strongest of any planet in our solar system. Jupiter's significance extends beyond its planetary grandeur. It serves as a valuable laboratory for scientists studying the formation and evolution of gas giants and planetary systems. Its intense gravity and radiation environment also provide insights into the extreme conditions found elsewhere in the universe. Section 5. Could Jupiter ever become a star? The question of whether Jupiter could ever become a star is a tantalizing one. Imagine a second star in our solar system, a brilliant companion to our Sun. While the idea is captivating, the reality is that Jupiter is destined to remain a planet. The laws of physics, specifically the principles of nuclear fusion and stellar evolution, dictate that Jupiter simply doesn't have what it takes to become a star. For Jupiter to ignite into a star, it would need to acquire a tremendous amount of mass, roughly 75 times its current mass. This additional mass would increase the gravitational pressure and temperature in its core, potentially reaching the threshold for nuclear fusion. However, acquiring such a massive amount of material is highly improbable in the current state of our solar system. The solar system's formation process has largely stabilized, with planets settling into their orbits and the remaining gas and dust dispersed. While Jupiter continues to accumulate some material, the rate is far too slow to significantly increase its mass. Even if Jupiter were to collide with another massive object, such as a rogue planet, the energy released in such an event would likely disrupt the solar system rather than transform Jupiter into a star. Therefore, while the idea of a second sun in our solar system is a captivating thought experiment, it remains firmly in the realm of science fiction. Jupiter, despite its size and composition, is destined to remain a planet, a testament to the power of gravity, but not quite massive enough to join the ranks of the stars. Section 6. Jupiter. A failed star or a spectacular success? The notion of Jupiter as a failed star is a misnomer. While it's true that Jupiter shares some similarities with stars like its composition and internal heat, it's crucial to recognize that Jupiter is not a star. It never was and it never will be. Labeling it as failed implies that it somehow fell short of its potential, but that's simply not the case. Jupiter is a planet, and a remarkably successful one at that. Instead of viewing Jupiter as a failed star, we should celebrate it for what it is, the largest and most massive planet in our solar system. Its gravitational influence has shaped the solar system's architecture, protecting Earth and other inner planets from cosmic bombardment. Its system of moons is a miniature solar system in its own right, a testament to the power of gravity and accretion. Jupiter's unique characteristics, from its swirling atmosphere and powerful storms to its intense magnetic fields, provide scientists with invaluable insights into the formation and evolution of gas giants and planetary systems. It serves as a reminder of the incredible diversity of celestial objects in our universe, each with its own story to tell.